student, you are welcome. Happy to have you here. And in this class, we'll still be talking about surds. You know, we've started surds in the previous class where we talked about the introductory aspects of surds, simplification, and how to use the rules in surds. Now, in today's class, we'll be talking about how to rationalize surds, especially using the conjugate of surds. Sometimes numbers are regarded as improper fractions, and when they are improper, you have to reduce them to a mixed fraction. And in the same way, if we have surds as the denominator of a number, it has to be rationalized to make the number proper. Let's see how this works.
Whenever we have a surd as the denominator of a fraction, it's a common practice in mathematics to remove such from the denominator. Example, we have 1 over root of 3. I will have to remove the root 3 by multiplying both the numerator and the denominator by the root 3. So 1 times root 3, I have root 3. Root 3 times root 3, I have root 9, which can be written as 3. So my final answer is root 3 over 3, which is exactly the same as 1 over root 3. What we've just done is called rationalization, and it simply means removing the surd from the denominator of a fraction. Let's consider some more examples. To rationalize the fraction 1 over root 7, I will multiply the numerator and the denominator by root 7. 1 times root 7 is root 7. Root 7 times root 7 is 7. So I've rationalized 1 over root 7 and I get root 7 over 7. I do same for 10 over root 5. Multiply both the numerator and the denominator by root 5, and I have 10 root 5 over root of 25. The root of 25 is 5, so I can simplify that by saying root 10 over root 5. Dividing through by 5 will go into 10 2 times. So my final answer should be 2 root 5. This means 2 root 5 is exactly the same as 10 over root of 5. Let's proceed and talk about how to rationalize using the conjugate of the denominator. Now, for each of the surds we've seen before, they had a single denominator, so it could be rationalized easily. In a case where you have a complex surd that has an addition or a subtraction of different surds, what do we do and how to rationalize this? We simply multiply by what we call the conjugate of the denominator. By saying conjugate, we mean reversing the signs. So if you had plus, we change it to minus, and when it's minus, it is changed to plus. Now in this case, expressing the numerator, we say 5 into bracket 3 plus root 2. And for the denominator, we write it out just the way we expand our brackets. So 3 times 3 gives us 9, and 3 times root 2 gives us 3 root 2. Minus root 2 times 3 gives us minus 3 root 2. And lastly, minus root 2 times root 2 gives us minus 2. Now we notice our middle terms in the denominator has plus and minus, so they simply cancel out. What we have left is 9 minus 2, which is 7. That is our answer. We can rationalize this fraction also the same way we did the first, by multiplying the numerator and the denominator with the conjugate of the denominator. And in this case, the conjugate has to be 5 root 3 minus 2 root 2, because the denominator has plus, the conjugate will be minus. Expressing the numerator, we say 3 into 5 root 3 minus 2 root 2. And for the denominator, we have to expand. Remember, while we expand the denominator, the middle terms cancel out, and we are left without a surd at the denominator. In this case, 5 root 3 times 5 root 3. 5 times 5 is 25. Root 3 times root 3 is 3. 25 times 3 is 75. 5 root 3 times minus 2 root 2, we have minus 10 root of 6. Now we multiply 2 root 2 times 5 root 3. 2 times 5 is 10, and root 2 times root 3 is root 6. Lastly, 2 root 2 times minus 2 root 2. We have 4 times 2, which is 8. Now the middle terms simply cancel out from this denominator. So we have 75 minus 8. 75 minus 8 should give us 67. And this will be our final answer. Now our first question will be an expansion question, where we have to express our answers in the form of a plus b root 2. So I'll write out my question. Bracket 5 minus root 8 into bracket 1 plus root 2. Expanding this expression by multiplying each term, I have 5 times 1 is 5. 5 times root 2, 5 root 2. Root 8 times 1 is root 8, and root 8 times 2 will give me root of 16. The next part is expressing my work in the form of a plus b root 2. Now I have to bring out root 2 from each of these expressions. Let's start with root 8. Root 8, of course, is 4 times 2. Root 4 times root 2. Now, if we have root 4 and root 2, we all know root 4 has the value of 2, because the square root of 4 is 2. So root 8 can simply be written as 2 root 2. I come back to my expansion. 5 plus 5 root 2 minus, I have to replace it with 2 root 2, and 16 is also 4. Now simplifying further, 5 minus 4 is 1, and 5 root 2 minus 2 root 2 should simply give us 3 root 2. It means the solution to the entire question is 1 plus 3 root 2. Now in the next question, I'm supposed to express this in form of c root 5. In other words, I'm expressing and writing it out in the simplest form. Now I have 80, the root of 80 plus 30 over root 5 in form of c root 5. Let's start this. The root of 80 can be broken down as the root of 16. Yes, the root of 16 times 5. And the square root of 16 we know is 4. So the root of 80 can be rewritten as 4 root 5. Okay? Now expressing 30 over root 5, I will have to rationalize. Rationalization is the process of changing the denominator from a root form to a normal rational number. And I have to multiply both the numerator and the denominator by the root, which is the denominator. Now, if I multiply by root 5 over root 5, my entire expression will be 4 root 5 plus 30 times root 5 is 30 root 5. Root 5 times root 5 is root 25, which should give me 5. If I divide through by 5, 5 into 30 will give me 6. So 4 root 5 plus 6 root 5 should give me 10 root 5. Now expressing this in form of c root 5, I have it as 10 root 5. Okay, looking at a different question, we want to rewrite root 80 in the form of c root 5, where c is a positive integer. Now the square root of 80 can be rewritten as the root of 16 times the root of 5. And the square root of 16 is 4, because 4 times 4 will give us 16. So we have it as 4 root 5. So the value of our C here should be 4. In the next question, a rectangle R has a length of 1 plus root 5 in centimeters and the area is root of 80 and in cm squared. Now we want to find the width, expressing it in the form of P plus Q root 5. Now we know our area is always length times breadth, or length times width. To find the width, it has to be area over the length. Yes, so now our width has to be area, which is root of 80 divided by the length, which is 1 plus root 5. Yes. In this case, we also have a root in the denominator. It means we have to rationalize. But in this case, we have to rationalize using the conjugate. It means simply changing the sign in the denominator. Now the conjugate of 1 plus root 5 will have to be 1 minus the root of 5. So rationalization, like we did in the previous question, you multiply both the numerator and the denominator by the conjugate. But before then, we can break down our root 80 into 4 root 5 as earlier discovered. So 4 root 5 over 1 plus root 5 times the conjugate, which is 1 minus root 5 over 1 minus root 5. Now multiplying, we can simply express it as 4 root 5 times 1 should give us 4 root 5. 4 root 5 times minus 5 should be minus 4 root 25. Of root 25 can be 5, so minus 20. 4 times 5 is 20. Now multiplying the denominator, 1 times 1 is 1. 1 times minus root 5 is minus root 5. Root 5 times 1 is root 5, and minus 5 times root 5 is minus root 25, which is root 5. Expressing further, I have 4 root 5 minus 20 over minus 4. If I decide to cancel out, by factorizing the value of 4 out of the numerator, I have 4 into bracket root 5 minus 5 divided by minus 4. Now dividing all through by minus 4, I will have minus 1. Let's expand this expression once again. Minus 1 times root 5 is minus root 5. Minus 1 times minus 5 is plus 5. So rearranging properly, I have 5 minus root of 5 as my answer, and I've expressed it in the form of P plus Q root 5, where my P equals to 5 and Q equals to minus 1.
Welcome back. That was an exciting class. Now I believe you can solve any question involving surds, from the introductory aspect to simplification types up to rationalization, including using conjugates. That will be all for surds. Till I get to meet you again, I always tell students to solve more questions. The student is as good as how many questions you have solved in a topic. Alright? See you in my next class. Bye.